Pythagorean Theorem Practice. This is a classwork worksheet, so I'm going to help get you started. This is coloring for these colors. And the way you work this is you use the Pythagorean Theorem to solve each problem for x, and then you color the heart with the matching shade. So, for example, if number 1, if x were 10, we would color this heart blue. Does that make sense? So I'm not so worried about the colors because I think once you figure out the answers, the colors are pretty easy to know where they go because these are all the answers at the bottom. The key is how to solve for the missing side. So we need our handy dandy Pythagorean theorem. So remember, it's A, and then this caret symbol right there means the next symbol is going to be a exponent. That's the little one at the top. A superscript is what they call it. So if I do that, that really means a squared. I cannot make a superscript. I cannot make the exponent 2 in this video because it won't let me. But I think you guys are smart enough to follow along. And then we have b squared equals c squared. Okay, that's our Pythagorean theorem. A squared plus b squared equals c squared. Oh, it won't let me do anything. Okay. So, let's look here. We need to know what is our A, B, and C. That's the first thing. So, what did Miss Walker tell you to do whenever you have a picture? What's the first thing you do? Do you just randomly go around saying A, B, and C? Nope, you guys got it. And if you've forgotten, go back to your notes. That's kind of why we take notes, so you can go back and look. You draw the arrow from the corner of your right angle, so this is the corner, to whatever is directly across from it. It's not curved, it's not bent, it's straight across. So here, where's the corner? Right there. So I would draw it straight across. Even if they put it backwards, I would draw it straight across. And why do we do that? So I'm not going to bend it and make it touch the x. That's not the point. The point is to go directly across, because that will then tell you what your C is. And remember when we did our notes, C is the most important. That's your hypotenuse. So once we figure out, let's see if I can make, oh, here we go, very thin. Let's try this one. If I can, oh, that's so much better. See, there's your C. Once you find out C, remember I said it doesn't matter what A and B is. You can mix them up because we have a property in math, that's kind of like a law, that says A plus B is the same thing as B plus A. Bonus points to who can ever remember and come up and tell me what is that property. What property says that you can say 4 plus x or x plus 4 and you would get the same answer. Okay, moving on. For this example, let's go ahead. We'll make A 4 and we'll make B x. So if we're using our Pythagorean theorem, A squared plus B squared equals C squared, we're going to square and solve for our x. So A squared, that's going to be 4 squared, plus B squared. Well, we don't know B, so we just put x. So x squared equals C, which in this case is 5 squared. First step, just plug it in. Second step, now let's get rid of as many exponents as possible. So 4 squared, well, that's 16. And again, use your calculator if you have to, no worries. Our x squared we can't do anything with because we still don't know what x is. 5 squared, 25. Now here's where algebra comes in and why we learned that unit first. Ooh, that's a squiggly line. You gotta get rid of this 16. Most of you know you end up having to take the square root, but you may not take the square root until you get x squared all by itself. How do you get rid of this positive 16? What's the opposite of positive? A negative, yep. So 16 minus 16, that's 0. Pat out. Now we have x squared by itself. But wait a second. If we took 16 from the left side, what do we have to do with this right side? You got it. We got to take 16 from here to keep everything balanced. Otherwise, this side is not equal to this side. So if we say 25 minus 16, we get 9. Now I'm going to change my color because I really want you guys to see this. This is the new part of algebra that we didn't do back in November and December. To get rid of a square, the opposite is your square root sign. They cancel each other out, leaving x. And again, just like with subtraction gets rid of addition, to get rid of the square on one side by the square root symbol, we have to do it over here too. You can't just do something to one side and not the other. That makes it unbalanced. So the square root of 9 is 3. And remember, your square root sign is, I think, about 2 buttons above, what would that be? The 9. I believe it's 2 buttons above the 9. And it gives me 3. So here's 3 in all its wondrous glory, and that's going to be blue. So then you would shade this in, hopefully much prettier than this. You would shade in the number 3 heart, this heart right here, blue. Does that make sense? Okay, I'm going to pause. See if you can do number 2 on your own without me. But if you're still having trouble, I'll come back and do it with you. Okay, we're back. Number 2. Again, we're pointing to, we've drawn our arrow. We did that before, and our arrow points to the 10. So we automatically are going to make the 10 C. The very first thing you label is the C. Then you can go back and make A and B. So this time I'm going to make A equal X and B is going to equal 8. Use the same formula. A squared plus B squared equals C squared. So A is X this time, so we're going to have X squared plus B, which is 8. And then we square that. And then C is 10. So 10 squared. Once you have that all filled in, now let's get rid of our exponents. X squared we can't do anything with, so we'll keep that. 8 squared, 8 times 8, that's 64. 10 squared, 10 times 10, that's 100. Remember, squared doesn't mean times 2. It means they want you to multiply the big number by itself. So 10 times 10 or 8 times 8. Now that we're here, x squared plus 64 equals 100. Before we can do square roots, we have to get the x squared by itself, which means we have to get rid of a plus 64. Subtract 64 on both sides. Right? Just like that. There we go. A positive 64, like you have $64, and a negative 64, you went to the mall and spent it all, means you have nothing left over. But the cool thing is, we now have our x squared by itself. That's going to equal 100 minus 64. Well, let's see. Let's go to my calculator here. Okay, so 100 minus 64 equals 36. So come back over here and we write 36. Yes, I want you to show me work for each problem. You can do it underneath the problem, on the back of the sheet, on a separate sheet and staple. Doesn't matter to me which way. Once you have your x squared by itself, to get x by itself, because remember, we want to know what x equals, not x squared. X equals whatever the square root of 36 is. So x equals, and we can, in your calculator, you have 36, and in my case it's over here, it's the x with the squared, because there are different types of roots that you can do. This is called a cube root, right, to get rid of to the third, but you guys won't have to know that till algebra. So here we have our square root, and that gives me 6. So x equals 6. So what is this? Red. So let me come up here and change it to red. Where do we see a 6? Right here is our 6. So we're going to color 6 red. Oh, it's so pretty. Okay? And you just keep doing that for each one, finding out what x equals. Now, in some cases, they don't want you to find the decimal version. For example, if we did the square root of 244, 244 square rooted, we would get an irrational number. That's a decimal that just keeps going on forever. Any square root that's not perfect is irrational. So you wouldn't have to find the actual square root, the decimal version. Once you got to this stage, right, if that was the square root of 244, you could go ahead and color this. That's all you have to do for this one. If you need any help, please ask your teacher. Thanks, guys.